Hello friends. So here we will continue in this video with the example of restoring division algorithm. Last video we have seen how the algo works. So here we'll go with one example. Let's say we want to perform the division of 15 by 5. Two integers are there. One is 15, another is 5. 15 is my dividend, 5 is my divisor. My first point is use same number of bits to represent your operands. So your 15 is what? 4 ones. We know 15 is 4 ones. That will be there in Q. And in A also 4 number of zeros will be there. One extra bit we used to take to represent the sign of the result of subtraction operation. So that is that bit. Initially it will be 0. And M contains the divisor. Divisor is what? 5. 5 is what? 1, sorry. 5 is what? 101. 101. So it is 4 bits this one. Extra one more bit I am taking because whenever we'll perform the operation, we'll take all these bits together. So these many bits are there in your M. And we need to perform subtract M. So subtract M means what? Adding the 2's complement of M. So what is the 2's complement of this binary combination? This one will come here directly and then all other, sorry, this one was, what was the 0, 0, 1, 0, 1. So what is the 2's complement of it? 1, 1, 0, 1, 1. So that is written here. Because we need to perform subtract M, so we'll keep it aside, right? So your inputs are now ready. Now we'll start the operation. What we will do first, we'll shift A and Q to the left. This is as a whole A, right? Including the sign bit. A and Q left to the, will shift to the left. So shift left will do. So this one will come here and then here this will be the vacated bit position. In case of shifting, vacated bit position is filled up by 0. But here, whenever we do division operation, vacated bit will be kept empty. Then later on, based on the result of subtraction, this bit will be set to either 1 or 0. Right now, it will be nothing, right? So it is vacant. Then next is what will perform? Subtract M. Subtract M means add this particular one with your A. A is this whole quantity, right? Including the sign bit. So 1, 1, 0, 1, 1 we need to add. 1 and 1 will give me what? 1 plus 1 will be 2. 1, 0. So this is 0, 1 will be carry. So 1 and 1 again it is 0. Then 1, right? Because that carry will be there. So here 1, here 1. So 11100 is my result after the subtraction. It is a positive result or a negative result. The sign bit is your 1. That means it is a negative result. So this bit position will be filled up by what? 0. So that only I am going to do. So see here, right now this is as it is. Then 3100 we have got. And then as this bit is 1, so we will set this bit as 0. Hope this part is clear. That Q naught bit setting is clear. Then next one is, see, after a subtraction operation, if Q naught is set to 0, then we used to restore our A. That means this whatever we have done, we need to nullify. So subtract opposite is your addition. Restore means add. So add operation we will do. So what we will add? 11100 is my right now A. What I will add? The original 5. Original 5 is positive 5, 0, 0, 1, 0, 1. After the addition operation, what it will become? It is 1, it is 0, 1 plus 1 is 2, so carry, 1 plus 1 is 2, carry, so 1 plus 1 is this, then this last one will be discarded. So ultimately what I got? 4, 1, sorry, 4, 0 and 1. This is nothing but this one only. So see, whatever you perform after the restore operation, the result will be this one will be discarded. The brown color one will be discarded. So 401. This is similar to my previous value of A. Before the subtraction operation, whatever was there, that will also come up again. Right? Restore is done. Next, what we will do? Here, see, our one cycle is over. And see, we need not have to maintain that cycle counter. Why? Because when all these bits of Q will become, means the boxes will come in all the bits of Q, that means our result is ready. So this also we can keep track of. No need to do the decrement of count and all. Though that can be also done, but here we are not doing it. Then next I'll start the cycle. So next again shift left. So this 0001 is there, and here see the operand is this one. So now what I will do? So see, next one more one will come here, right? So 301, this 0 has gone, this 0 has come at this place, and this part will be 110, and one new box is created, right? One new box is created after the shift operation. Done. Then what we have to do? Subtract. Subtract means what? See here, 3011 is there. Subtract means 11011 we need to add. So 1 plus 1 is 2. So this is carry 3. So it is carry. So it is 111. 410. So what is the sign bit? 1. So your this bit will be set to 0. Right? So that I will do. See here. Subtract operation we are going to do. Subtract means adding the 2's complement. So we'll be doing that. After the operation, the result is C, 410. We have seen that. So due to that, this bit will be set to 0. Whenever this bit is 1, this will be 0. Whenever this is 0, this will be 1. Right? Already we know this. So see, after this operation, the negative result, that means subtraction is not successful. So what we will do? Restore. Restore means add m back to a. So see, 4 ones are there, 0. Then I will add m. M means this one. 00101 I will add. What it will become? 1 1. This will be 0 0 0. Last one will be discarded. So 3011 it will be. See, 3011. See, if you have any confusion, you should know that this result will be similar to my this one only, right? So this one will be the value. Done. After this, we'll start the next cycle, right? So again, we'll shift left. So next time, this one will be also considered, right? So this time it is 7. 111 means 7. So this time we are going to get success. So 111 we have got, and this new one more box is created. Now see what we'll do, subtract operation. So see, right now we are in this situation. Here the values are like this. Now we need to perform subtraction. So if we perform subtraction, 1 plus 1 will be giving me 0. This 1 is carry, so 3 ones, 1. So here it is 0, right? Then here also it is 0. Here also it is 0. The last one will be discarded. That means, I'll show you here. Actually there it is not coming properly. 0 0 3 ones, and it is 11011. After the addition process, see, 1 plus 1 is 2. So 0, 1 carry. 3 ones means 3. 1 carry. So it is 0 because 1 plus 1 is 2. Here it is 1 plus 1 is 2. Carry. It is 2. Carry. So last one will be discarded. So what is the result? 3010. You need to understand the last that carry that comes out of your MSB addition, that has to be discarded. Please do not consider that as the sign of your result. Then it will be a erroneous one. So it is 00010. So what is the sign bit of my result? 0. 0 means what? Here the bit will be set to 1. Here the bit will be set to 1, right? And then do I need to do restore? No, because this is nothing but after the subtraction, whatever I used to get, this is the remainder. So, but remainder is 10, smaller than my 5. Then I'll consider one more 1 here, right? 101 it will become now, right? So see, again we'll perform shift operation. So shift operation means this one will come here. It has come here, and one more new box is created. So now if we can fill this box, that means our result is ready. So now see 101. So this is 101. We'll subtract what? That 5 only. So same value na. So subtract means what? This is negative 5. That is, so 00101, and it is 11011. What it will become? This one is 0. This one will be 0. This one also it will be 0. This one also it will be 0. Here also it will be 0. And last one will be discarded. So all 0 we have got, right? And as this result is positive, so my Q naught bit will be set to 1. As all the boxes are filled up in Q, that means we have completed our operation and our result is ready. Where is our result? quotient bit in Q and remainder in your A. This part only I am going to consider. So my A will be all zeros and Q not means quotient is your 0011. That means what? It is 3. And what is remainder? 0. Anyways, we know 15 divided by 5 will be 3 and there will not be any remainder. That means it is 0. So hope this explanation is clear. See, we need to practice a lot this type of numerical, right? And do understand the carry out of MSB addition is discarded and one extra bit is taken in A. And whenever you are performing addition and subtraction, that time take the length of your M with respect to the total length of A inclusive the sign bit. If we remember these points, and we'll follow our steps carefully, definitely we'll come up with a correct result, right? Hope this much is fine in this video, and then in next video we'll see another one more algo on division. Till then, thank you, and if you are liking my explanations, then please do not forget to like my videos and subscribe to my channel. Thank you.